Slot is an extruded cut that passes through both this wall and the rib and was controlled by the axle, which was made visible again. The last step was simply to combine the fender, the wall, and the rib. It's not clear to me that it was necessary to do things this way. Probably when both of these extrusions were made, they could have been merged at the same time as they were created rather than merging them after the fact. So that would have saved a step. Phase 4 is going to be to add this raised step running around the perimeter. On the upper fender, we actually cut out a step, which could be considered to be a recess step. In this case, we actually have to grow a raised rib or step that's going to fit up into the step on the upper fender. Here you can see that step on the upper fender, and here we can see the raised rib from the lower fender going up into it. You can see that there's an intentional small amount of a gap here and here to account for tolerances. So if the step was 0.035 wide on the upper fender, we should make it 0.04 wide on the lower fender, and if it was 0.035 tall on the upper fender, we'll only make it 0.03 tall on the lower fender to create a 0.005 gap on both of these interfaces. Just like we did for the fender liner, what we're going to do is extrude this wall down from our upper plane, do the same for a wall back here, and then use a surface to cut away the excess material so that we get a consistent 0.03 inch tall wall running along the parting line. Rolling back to the beginning of this phase, we start by extruding this wall from our upper plane. Let's take a look at the sketch for that. This sketch is made by offsetting this outer edge inward by 0.04 inches and then taking that offset edge and offsetting it again inward by 0.03 inches. We see that this line falls on this upper parting line surface, and this line falls in the vicinity of the lower well of the fender. When we extrude this, some of the extrusion is going to hit this surface, and some of the extrusion is going to hit this surface. This means we can't use the up to surface command, but what we can use is the up to next command. So what will happen is this will keep on going until it hits something. So part of this will hit this, part of this will hit this, and it'll just keep on going until it runs into some sort of a barrier, and then we'll stop the extrusion. You need to make sure that when you look straight at this sketch that there's always going to be something in the background for this extrusion to run into. If this sketch were to leak out over in this area here, there won't be anything to stop it in this vicinity, and the extrusion will fail. Therefore, what you want to do is copy this edge from this edge and make sure that none of it is overhanging anywhere throughout this sketch. And here we can see that our solid body, there's always some solid body behind the sketch that will act as a boundary or a barrier for this extrusion to run up into. And while I'm at it, looking at this area, I've also built a little bit of an extension in this area so that when this extrudes down, it's going to fill up a little sliver that would otherwise be formed in this area. There's our extrusion using the up to next option. And we'll simply do the same thing, same procedure on the back wall here. Neither of these walls at the moment are merged with the main body. I want these walls to only be 0.03 tall, so I'm going to copy the offset surface, the split surface one more time upward by 0.03 and use that to cut off the top of those walls.